I think everybody who's here has probably seen a bloom, so that's not, but these are the famous blooms, okay? This one in particular, this is Taiwu in China, which I actually had an NSF China grant in 1986, and I was supposed to go to China in 1989, but NSF wouldn't let me go because of a little thing called Tiananmen Square. And so after that I went for several years, just over the summer periods for 6 to 8 weeks, and we would systematically go across China, starting with Vietnam all the way up to Inner Mongolia. And at the time, this lake is China's third largest natural lake, and in the 80s this lake was considered eutrophic. That is, it had nutrient levels, but it didn't have massive blooms of cyanobacteria. So in 20 years, that lake went from mesotrophic, eutrophic to hyper-eutrophic. And microcystis completely displaced everything in the lake. Macrophytes, other algae, fishing is no longer possible. The fishing they had 200 species of fish, they have a half a dozen left. And it was all because of, after the Cultural Revolution, populations shifted into the urban areas. So this is located roughly between Shanghai and Wuxi. Well, it's near Wuxi in Nanjing. And of course, several million people have now settled around this lake. And it went hyper-eutrophic because of sewage, direct sewage inputs, agriculture, extensive overdevelopment of the shoreline areas. They put in a crab, freshwater crab aquaculture farm penning, and those crabs helped eat all the macrophytes, which then increased the nutrient loads. So that's kind of the showcase lake for China and the world, someplace that could go within 20 years to. This is what you have on the lake virtually 12 months out of the year now. So those are some, these are just some other pictures. Here's Lake Erie. Lake Erie, of course, is our poster lake for eutrophication. Lake Erie's had issues forever. But if you'll remember, most of you aren't old enough like I am, but when I first started, the mantra was Lake Erie was dead. This was in the 60s, 70s. And it was due to cyanobacteria blooms. But it was a nitrogen-fixing bloom called a phanozonon, which implies that nitrogen was limiting. Through the joint efforts of Canada and the US and the Joint Commission, there was a serious attempt to sort of reverse point source nutrient inputs. And it did, it worked. It slowed and stopped eventually the blooms. Now other things happen, you know, zebra mussels and things like that too, which do a good job of eating up algae too. But it's interesting, the zebra mussel infestation actually contributed to a reestablishment of cyanobacteria because zebra mussels selectively filter the algae, and they don't like cyanobacteria. So they actually reject Cyanobacteria microcystis in their pseudofeces, thereby helping to re-inoculate the system while retaining all the other good algae like diatoms and green algae. So around the early 90s, we started to notice, I get reports of microcystis blooms. And so we looked at it, and sure enough, they were microcystis and they were toxic. And so this actually is from 2011, when there was a massive bloom. This is the Western Basin, which is where most of that's the shallowest part of the lake. It's also where the nutrient inputs are the greatest. Mauming River and places like that, Toledo. And so it's now a major thing for them to work on. Cyanobacteria has as well. Some of these other lakes, this is actually Lake Okeechobee down in Florida, another problem lake. And this is also Taiwu in China. So this was just to kind of set the... of course, this is a 4-series thing. I'm now halfway through once again. The sessions that we're going to run, this is pretty much how it's going to be. I'll get started here shortly with the first main lecture. We'll take a break, and they want to have sampling and then some taxonomy and a lunch. And then one of the changes from last year is that the students' input was that you'd like to see a bit more on management and mitigation. So that's what I've got the last lecture for at 2 o'clock, and then we'll shift over to the other lab for looking at some algae. One of the things from last year was that apparently taxonomy doesn't appeal to as many people as it does to me, so I've reduced the taxonomy time we have, but there's still plenty of time. I'm going to lead you through a taxonomy key, and I have some water samples that I know what's in them, so you can use those as examples for keying. And we put into the announcement that you could bring your own water samples, and we have a few water samples here that clearly look like some cyanobacteria. So there are plenty of things to look at over there in the lab this afternoon. Bev will mention some of these, but I also wanted to put up, last year I commented that most states now have some sort of HAB monitoring program. CDC had actually grants for 10 states, then that program ended last year. And Oregon had one of those programs funded, and California did not. So I'm glad to see that you're sort of taking that interest again and renewing it and setting aside within the Water Board program these efforts to inform and monitor and help set up the various groups that look at these things. So these are some of those websites that both the California Public Health Cyanohab website, the SWAMP program, which is within the water boards, is greatly redone, and they're also redoing even more of it, and Bev will talk about that. The CC HAB network, the Division of Drinking Water, and the Marine HAB website. Obviously, when it comes to marine harmful algal blooms, California has had a much longer effort in this because you had some of the original red tides back in, well, actually pre-World War II even. And another history lesson was that there was a fellow named Ed Shantz at Berkeley who actually identified and characterized the first phycotoxin, the so-called red tide saxitoxin. And he characterized it and showed that it was responsible for some of these shellfish poisonings. But he ended up going to work for the Army at Fort Detrick in Maryland, and hence saxitoxin supplies are probably the best there are at the, still they have gram quantities of saxitoxin at Fort Detrick. That's another story. Some of the documents you can get off the CC HAB history news and document releases, and the action levels, decision tree, and narratives. So those will get some more. Likewise, the US EPA, when it comes to national programs for harmful algae, it really began with NOAA and Marine. So all of the funding from Congress typically went through, and still does for the most part, it goes through NOAA. And all of the freshwater HAB research was excluded from that funding for many years. It wasn't until literally just the last funding round with Congress that freshwater HABs were funded through NOAA, through the EPA. So as a consequence, the US EPA has upped their game significantly, and they have several websites. These are the main ones. They have a regular HAB discussion group and webinars. The proceedings, they have a Cyanohab newsletter. So you can get all of the EPA, US EPA documentation as well from these websites. Some of their more recent things, they've now set guidelines finally for microcystin and cylindrospermopsin, two of the main phycotoxin, cyanohab toxins. So they're coming right along. And there are some funding programs too now available through them.